So this is a talk about Encore, building better software faster. And the motivation for this is, I think as programmers, we've all heard variations of these questions. Adding this feature should be quick, right? Or this critical bug can't be that hard to fix, right? Or changing this behavior should take about an hour, right? And to which our response as software engineers, unfortunately, usually is something like this. Not quite. And so you have to ask yourself why that is. And I think thinking about this problem for a very long time, I think, it's very easy to look at software engineering from a very high level and think that it looks really easy. So we see a web page and we think it can't be that hard to add a simple button to this page to upload an image. Or we see an app and we go, this app is so simple, I could build it in a week myself. And actually, we're often guilty of this ourselves as software engineers. But then when you actually get into the details, it ends up being something like this. Like the classic joke about how to draw an owl. You start by drawing some circles, and then you draw the rest of the owl. And this is kind of what software engineering is at a very high level. But when it comes to actually doing the details of building a real-world application, there are 100 of details that you don't initially think about when you're trying to just describe the behavior at a high level. And another way of thinking about this is to look at the software development process. And you can kind of simplify it as, first, you have an idea of a feature or a product that you want to build. And then you build it. And then you ship something to your users. And then you repeat. And then you just do this over and over as quickly as you can. And if you look at these two boxes, leaving aside the idea part to humans, the build it stage is usually dominated by editors and frameworks and programming languages. It's how we write the code. And the ship it phase is almost exclusively about cloud providers, right? So that's how we deploy code these days, is we use AWS or GCP or Azure or Heroku or whatnot. And this is great, but there is one big problem here, and that is that they're independently optimized. And by what I mean by this is that when you have an editor or a framework or a programming language, you don't want to make any assumptions about where the code will be running. So you don't want to build in assumptions that, oh, this only works with AWS. You don't even know if they will be using AWS or if it will be running on a computer on your laptop or on premises or GCP or so you end up making all frameworks and editors that are completely agnostic of where the code will eventually run. And on the other side, with the cloud providers, it's the exact same story, because cloud providers want to support any customer, any application. You should be able to take it and run it on their infrastructure. And so what they are doing is they don't want to make any assumptions about how your application is built. And so that's how we end up with Docker containers being the universal unit of deployment these days, because the cloud providers don't want to know what's going on inside your application, because that means that this is such a powerful abstraction, because it means that they can support any application at all. But why this is a problem is there is clearly work to be done to integrate the the code you're writing with where you're deploying it, right? You have to do configuration, you have to set up like how to connect to the database, and you need API keys to provision servers and so on. So all of this work falls on you as a developer. And this is what I mean by this isolation of these two boxes is causing us a lot of problems in the development process. And another way of thinking about it is what we think the software engineering is like. So we're starting out like this, and then we write some code, and then we ship it to users, and all the graphs go up and to the right. But in practice, when you're building a simple API, it looks more like this. So you have to figure out first, what framework do you use? And you do some Googling. And then you copy paste some template code that you find on Stack Overflow or the internet. And then you need a build pipeline. So you do some more Googling and figure out, do you use Jenkins or Circle CI or the next thing? And then you figure out how to actually use that thing. And then you do the same thing for a deployment pipeline. And then you realize you should use Kubernetes, but you never remember how it works. So you do some Googling again. And next you want to provision a database. So you click around in the cloud provider's UI and finally get something set up. But then you need to figure out how do you actually store, how do you store the database password securely? Because we all know you should never paste passwords in your code base. So you get a bit wide-eyed. It seems like this is getting to be a lot more effort than we anticipated. But unfortunately, we're really just getting started. So we need to figure out how to connect to the database. And then when we have done that, we have a mostly working backend application, actually. But now we need to, if we want to develop it locally, we need to set up a new database on our own computer. So we copy paste some logic to support running it either locally or in production with different passwords. And we figure out how we need to set up our machine to actually run the database and set up all the tables and so on and so on. And then we need a way of migrating the database over time as we make schema changes. And this also should work locally and be part of our deployment pipeline so that we keep our databases in sync. And then we need to figure out a communication protocol between the front end and the back end for making API requests. Usually this is REST or HTTP and JSON or gRPC, but you have a lot of choices here. And then we want to do some documentation, but let's be honest, we probably skipped this part. And then we need service discovery so that clients who want to talk to our backend service can actually find it on the internet. And also when you have different backend services, we also need service discovery to talk between them. And at this point, we go kind of like this, but we're still not done. We decide we want to add PubSub for sending asynchronous messages between services. So we figure out how to add that. We scour the internet for the right library. We finally find it. And then we need some more API credentials. Then we need to figure out how to scale this thing, how to handle increases in traffic. And at this point, you look at the calendar, and what you thought would be like a 2-day thing has turned out to be 2 weeks or 2 months. And at this point, you haven't even written any business logic. And so you kind of go like this, or like this, or like this. And eventually we get done with all of this stuff and we write some business logic, and finally we're ready to ship the code to production, and we pray that everything works, and immediately your service crashes in production, because at this point you have so many differences between your local development environment and production that something is just incredibly misconfigured, everything is on fire, and you kind of go like this. So this is like life as your average backend engineer in my experience. And so my conclusion with all of this is we need a better way of building software. We need a better user interface for building software. And this is where Encore comes in. It's trying to get us out of this mess that I just described. And so what is Encore? Well, it's APIs as simple functions. It sets up and manages databases for you. In the end, it deploys your whole application as a serverless app. It generates API documentation automatically. You write your business logic once, and then you run it anywhere, whether that's on your computer, in production, in a pull request, in a test environment, or whatever. So there are no build or deploy systems that you need to manage. There are no servers to worry about. There is no infrastructure to provision. And most importantly, there is no boilerplate. So instead of this, we go for just this. Just pure and simple business logic, nothing else. And so if we go back to this picture and how the problem I described stems from how these two pieces are independently optimized, you can think of Encore as kind of integrating these two in a very, very tight manner so that we can create a much better developer experience. So I'll stop here and see if anybody has any questions before we jump into a live demo. All right. In that case, let's jump right in. Now to find the right. Let me do this actually. Okay, can you see my screen?
Yes, could you make fonts a little bit bigger?
Yes, absolutely. How's that?
Perfect. Perfect.
Okay, and then I will. There we go. Okay, so here's the hello world of Encore. So what's happening here is we have a regular Go package, which has a single function with this comment here. And this comment is telling Encore that this is a public API. The function is called world, which will be the name of the API. It takes one parameter after the context and returns either a world response or an error. So with this information, Encore will do a lot of static analysis to figure out that we have this API. We have, this is the input parameters, and this is the response parameters. And so with this, we can, to run this application with Encore, all you need to do is type Encore run. And you will see that Encore has parsed your application. It registers the endpoint hello world, and we can now call it on this URL. So this is how it looks like. We specify a name and go and pull it. And we can see that we get the output. We can also go to this this URL, and we can see that this is the local dashboard for development. And here you can see that Encore has not only is running it for you, but it also generates API documentation. So here we can see that for the hello service, we right now have one endpoint. It takes a name, which is the name of the person, and the response is has a single field message, which is the greeting response. And you also get live streamed logs if you are looking for that. So this is useful and all, but it would be nice to do something more complicated. So let's add a database. So to create a database with Encore, we create a migrations folder, and then we add a SQL file. And then we just type the table name that we want to create in this case. Now let's just create a people table, which has name as the primary key, and then count, which is the number of times we've met that person. And then instead of just generating a static greeting, let's instead generate a greeting on the fly. We'll take the context as input and the name of the person, and we'll generate a greeting string and an error. So what we want to do now is we want to call the database. So with Encore, all you need to do is import the storage SQLDB package. And since you have a migrations folder and you import this, Encore will automatically set up the database for you. And then it will connect to the database and manage the database password. And it will do this both on your own computer, like I'm doing right now, as well as in production. So we can just call this, and we can specify query row. And we will pass in the query. And what we will do is we will do an upsert. Go away. So with this, we will insert into the people table. We will set the parameter 1 is the name, and the default count will be 1. But if the row already exists, we will instead increase it by 1 and then return the new one. And then we will pull this out of like this. Let's just return an error if something went wrong. And then if this is the first time we meet the person, we will say, let's be nice.
Cyrus, moment.
And if count is greater than 1, we will say does that make sense? And then instead of doing this, we will fetch it from, we will call generate greeting. So this is all you need. If I didn't screw something up, this is all you need to set up a database with Encore and then connect to it on your local computer. And so here we need to specify people count. And here you can see the first time we call this, we will get nice to meet you, Poland. And the next time we call it, we will see that it increments it like we expect. So now we have a working database. Now, this is all useful, but it would be great to get this working in production. So let's take this and push it to production. So now let's head over to our, this is Encore's web interface. So Encore is not only a framework, it is also a platform that manages your application and infrastructure. So let's take a look at this production build. We can see that now that we pushed it. Oh. So here we actually see that I forgot to update the tests. So this reminded us of that. So let's update the test. So here is a test that calls the world endpoint and passes in world. And we want this. And as we can see in the test failure, we can see that it expected hello world, but we got nice to meet you world. So let's update this. And while we're at it, we can also add a second call. And with Encore, it also sets up the database for your tests. So we can actually test this, make sure everything is working correctly. So it's dot. And there you go. So let's commit this. Let's give this another go. So we can see it's already building. Let's just wait for the tests to go through. There we go. So now that the master build went through, we actually need to go ahead and do something, which is when you have a production environment, you actually need to configure the size of your database because it will actually provision a real database for you. And since this is just a demo, it will start with a very small one. And let's just commit this again. Apologies for that. I should have done that before the demo. So once this the test pass, it will deploy to production, and then we'll be able to run it in our production environment. Here we go. And we can see that the test deploy is running, and now it's it identified that there is no need to provision any infrastructure because we're running against Encore's cloud, which does this for you. And then it will migrate the database for you, set up all your code, upload the Docker image, and then deploy it. And this is all deployed to Kubernetes behind the scenes. So now let's the way you call this in production is by you take your app ID and then you call encoreapi.com and then the name of your environment. And here we can see now we're talking to the production environment. And we can see that we are working production installation with a database. And again, you can go ahead and look at the API that you have, the API documentation for this code. Now, this is all very useful, but there's much more to Encore that we can't really take a look at with such a simple example. So I prepared a slightly more complicated demo, which is a very simple Trello clone. And this will demonstrate some of the more interesting features of Encore. So here we have another application which has two services. So we have the board service, which manages the Trello boards, and we have the card service, which contains all the card information. If we take a look at the card, we can see that we have a card ID, we have a board and column it belongs to, and we have a title, a description, and a sorting order. And if we take a look at car.go, we can see that this is very similar to the old example we had, where we just have some APIs to create a card in this case. Now, what's interesting about this is that we're saying this is not a public API. This is an internal API that can only be called from other services. So you can't call this as a front end, only from other backend services. Now, this is slightly more complicated. We're computing the maximum sorting order and then inserting it at the end, but you get the idea. It's very similar to what we had before. The board service is a bit more interesting. Here we have two tables. We have a board table, which just has a name and create timestamp, and a column, which has a board ID, a name, and also the order of the columns. If we take a look at the board service, we can see that, again, we have some APIs to just create a board, to list boards, and so on. But what I wanted to show you is the get endpoint. So with Encore, let's say that we want to retrieve a board. And as you can see in the board, we have a list of columns. And in the list of columns, here you can see that we also have the cards. But these cards belong in a different service. So what do we want to do in the get endpoint is we want to call the card service and fetch the cards and merge them with our columns. So the way this works is we have a simple database query to fetch the board. And then in parallel, we will use an error group to, in parallel, fetch the columns, which is happening here. And this is an API call to the list columns API in the board service. And then in parallel with that, we will call the card service to get to list all the cards for this board ID. And as you can see, this looks like a function call. And in fact, with Encore, it is a function call. So with this syntax, Encore understands that at this point, you are calling the list endpoint on the card service. And when you then compile and run the code, it will replace this with a regular API call for you. So you don't need to worry about HTTP and JSON and serializing and deserializing and validating. In fact, you can just write it as a regular function call. And if you get it wrong, you will get compile time errors that you're calling the API with the wrong fields. So when we get the response, again, it's been already deserialized, so you can just use it like a regular result from a regular function. And then we combine the columns and the cards. Fairly straightforward. So if we run this, again, you just type Encore run and everything gets set up for you. And here we can see that it sets up a whole lot more, right? But an application like this is, it's not as easy to understand from the command line. So I went ahead and created a simple front end for this as well. So here's a simple front end, which is a bit more code since front ends are a lot of boilerplate surrounding the HTML. And here we can see we have this is all in React. So we have a board, we have a card component, we have a card detail, and so on and so on. But you know, when you're writing front ends, what ends up happening a lot is you have a lot of boilerplate on your end to integrate with the API. So with Encore, we since Encore understands your application, it can actually generate a client for you. So to show you how that works is we can type Encore generate client, and then the name of the application, which in this case is like this. And then we can specify the environment that it will pull the API definition from. And since we're just doing this on our computer, we'll specify environment dev, and we will say, please output it to the lib client folder. And since this ends in TS, Encore understands that this is, we want to generate TypeScript code. So then we can see that it generated the client. for us. And this is now a fully typed version of the very same API with documentation, all the fields. It's broken down by the service so that it's very easy to refer to all the APIs in a very natural way. You can see that it's referring to other types. And then at the very bottom here, we have this is the service client, and then at the bottom here we have the thing that actually does the JSON for us. And I'm gonna go ahead here at the bottom. We have it sets up a default client against production. But if we just want to talk to our own local development environment, it's as easy as changing this to dev. So if we run this, I guess I'm running this in another console. Oops. Oh, let's use another one. And we'll wait for this to compile. Come on. Okay, here we go. So this is talking to our local Encore application here. And you can see now that we ran it, it ran the board.list API. So let's create a board. So we can see that this resulted in more API calls. We can even create a column. There we go. And we can even create a card. But if I'm right about this, this is going to explode. Oh no, something went wrong. So it looks like there's a bug in our backend. So let's take a look at the next feature that Encore comes with. Here is the list of all the requests that have been happening to this backend. And we can see that we have a few things that are throwing errors here. Let's take a look at this one. Now, Encore comes with distributed tracing, which is automatically compiled in to your application. So you can see exactly what is happening every single request. And here we can see that there was a failure in the add card API. And what's more, it's also parsing the inputs and outputs to every step. So here we can see that this request was called with these parameters. So board ID 2, column 2, title test. And this looks correct. We can see there was one database query, and it took 1.6 milliseconds. And we can also take a look at what every Go routine that is participating in this request is doing. So here we can see that this is doing a database query. And here we can see that the query was this. And the error is that the column ID does not exist. And this is correct because it's not called column ID, it's called ID. So if we run this again, and we refresh, now we can see that it's working. And when you refresh, it's still there. And if you want to take a look at some more traces, I explained before that the board.get endpoint is using concurrency to fetch these things faster. And when you take a look at the trace, you can confirm that this is happening. So here you can see that the board.get API is calling two other APIs. It's calling car.list and board.list columns. So looking at board.get, we can see that it's first making a database query, and then in two different Go routines, it is calling the board list columns API and the car.list API. And we can see the request and the response for each one. So this is a very, very powerful way of debugging things that are wrong with your application. So now that we've fixed this bug, let's push it. But when you're doing development, you don't want to push things to master straight away. So what we're going to do instead is we're going to integrate this with GitHub. So now we're moving over to the Trello project, which is the name of my Trello clone in Go. And let's link it with GitHub. So now I've linked it to my GitHub repository. And then nice. So let's push this to GitHub. And head over there. Oh, oops. I need to first set up the master branch, actually. So give me a moment. Okay, so now that we have a master branch that is the right branch, the main branch is master. Let's create a pull request. And if all goes well, Encore will automatically build it and test it. And this is already happening because I pushed it and it happens on push. Now you can see that it has also been deployed. So if we go back to here, you can see that Encore has automatically set up a preview environment for our pull request. So we can take a look at that. And here we can see that this is now running the commit that we built. And so if we want to verify that this is working in our front end, we can go back to the front end, and instead of using dev, we can run it against the PR1. And because this is a private pull request, it's not running against production, we will actually not be able to access it from here. This should throw an exception. And so what we need to do is we need to start a tunnel, and this is how you authenticate. So now that this is running, it's actually VPNing, and it knows that I'm connecting. I thought. Okay. So for some reason, I thought that would work, but I must have done something wrong. So Sorry about that. But in the meantime, let's go ahead and merge this. Once you merge it, the preview environment goes away. And we're now building the merged pull request. And hopefully the tests will pass, which they did. So the deployment is done. So instead of trying against our PR environment, let's just talk directly to production. Oh, I realized now what was the problem. It was not broken against the PR1 branch. It was just trying to access a board that didn't exist. So I should have been able to show that actually. So now we're talking to production, and as you can see, this is there are no boards here because we were running it against local development. You can add a card, and you can also go ahead and you can update the description. And you cannot actually move the cards yet. That's still work in progress, but you get the idea. So this has been a very quick demo of Encore. There's a lot more you can do with it. You can use it to manage your secrets. If you have API keys, you can use Encore secret set. You can, of course, the things like tracing work equally well in production. So now that we've used this, you can look at the traces in production as well. You can see exactly what's happening. Here's the request I made to update the card. You can see that this is what's happening. We had one database query, and then we had an API call, and so on. You can create production environments that are integrated with any cloud provider of your choice. So if you want to deploy directly to Azure, it works just as well. And I'm going to stop there. Hope this was interesting. Happy to take any questions. And for the last slide, if you're interested in trying Encore, it's in private beta right now. So reach out to me on Slack, André, or email me at andre@encore.dev. Thank you so much.
Okay, guys, do you have any questions? André?
I do have a question.
Awesome.
So is there any overhead in performance when running the tracing in production, I mean?
One second, I'm trying to pull up the participants so I can actually see people. There we go. There is overhead, but it's very, very small. So the way it actually works is it's using a modified Go runtime. And in the Go runtime, it's adding, it's building an in-memory log. And because there's so much static analysis, most of the expensive things are actually pre-computed and offloaded to the Encore servers. So the only thing the application is doing is recording like, oh, we got this request, which is these bytes, right? And it needs to fetch those bytes anyway. So it's all there in memory already. So the tracing overhead is much, much lower than traditional tracing solutions. And you also don't need to do anything for it, which is the best part, I think. You don't need to add like, annotate this API call with tracing information. It just built in and works out of the box. So it's very low overhead. And as you can see, it's much more expressive. The information that you get is much more extensive than you're getting from traditional tracing solutions, because it's all compiled in for you. And those are the sort of things that you could add to traditional tracing solutions, but nobody does because it's so much work, right?
Yeah. And can we disable it in production on Encore?
You can't right now. That would be very easy to do, but I think a better solution is to it can automatically sample just a small proportion of your requests.
Oh yeah. Okay.
That's the traditional way of handling it. But actually, it's so low overhead that compared to like traditional RPC and traditional tracing, I'm not even sure you can detect it.
And also, I had a thought about A/B testing. So, is there an idea of creating A/B testing out of the box for somehow for the backend stuff?
Absolutely. I mean, the idea is with Encore is really to take all of these, concepts like A/B testing and tracing and database management and secrets that we're doing every day, and then just make them 100 times easier to use. So A/B testing is very much up there. Logging is the same thing. Easy debugging in production, so you never need to worry about like, how to reproduce this issue. Those are.
What about different transports, different than HTTP?
So behind the scenes, when you're talking with APIs within Encore, it's actually not using HTTP. It's a custom binary protocol. But I think it's very much I definitely plan on supporting like, we want to expose our APIs using protobuf or gRPC or whatever. That's very easy to do. It's just not been prioritized just yet.
Okay. I also have a question. What's the SQL's flavor?
Postgres.
Postgres. Okay. And also the only database for now?
Yes. So plans of adding more, but I think Postgres is a good start for a lot of applications. If you really want to use another database, of course you can integrate it with it the traditional way. It's just more work, right?
Yeah, sure. Also, I had a question about the command line completion you are using. Is it a feature of VS Code or Z Shell or what?
That's Fish.
Fish. Okay, I've heard of it, I think. That's it from me for now. I think I will have more questions, but I will post them somewhere.
Yeah.
And thank you. Yeah,
absolutely.
Great job. Actually, I've seen how the project is developing, and it's really great.
Thank you.
And I did not expect the polished twist. Yeah. Thanks.
Thank you.